Assalamualaikum warahmatullahi wabarakatuh. My name is Nabila Karhawi, student ID 23 and I'm from Operational Research 1, Class A. In this video, I would like to explain about the sensitivity analysis of linear programming. So first of all, linear programming is a method of operational research that used to find the best or optimal solutions by maximizing or minimizing a linear function of several variables involving constraints so that the resource allocation achieve a desired outcome. So, the first semester students in the industrial engineering department often face difficulties when making their class schedules. And one of the main problems is that many classes are held in the late afternoon, which is this class is held in the last shift, which takes place from the 4 p.m. until 5:40 p.m. So, by using a mathematical model with a linear programming approach, the students can get a better class schedule that fits their preferred time and helps reduce the number of afternoon classes. So, first thing we need to do here is decide the decision variables. So here the decision variables is represented as Xij, which indicates whether students selects the J class of the I course. For example, here the X11 stands for Analysis Estimasi Biaya A, and so on until the X82 that stands for Sistem Logistik dan Rantai Pasok B. And after that, we need to determine the objective function based on the problem that we've got before. So here, the objective function is defined as minimize z equals to k times xij, where k here is used as the weight to show how much a class contributes to the afternoon schedule. So if a class doesn't take place in the afternoon, so the weight is 0. If the class takes place in the afternoon only during odd weeks or even weeks, so the weight is 1. But if the class takes place in the afternoon during both odd and even weeks, or we can say every week, so the weight is 2. And after that, we also need the constraints for the limitation to solve the problem. So the first constraint that we've got here is the number of classes available for each course. For example, here, the x11 plus x12 plus x13 plus x14 equals to 1. It means that the student only can choose one of the courses that stands for Analysis and Estimasi Biaya, only choose one class. And after that, we also use the constraints of class schedule conflict, which is divided by all weeks, even weeks only, and odd weeks only. For example, here, we've got the class schedule conflict between x13 and x32. So the students only can choose one between these two classes. And after that, we use the lingo to find the results of the optimal solutions. So as you can see in this screen, we've got these variables that all have a value of 1 in the lingo. So it means that these classes are the part of the base schedule found by the model. So these selected classes follow all the rules, avoided schedule conflicts, and help reduce the afternoon classes, which is, as you can see here, we got only one class that held in the late afternoon, which is X74, that stands for Perencanaan dan Pengelolaan Produksi D, that held in late afternoon GASAL. And after that, we use the sensitivity analysis here. So the sensitivity analysis is used to evaluate how changes in certain failures affect the stability of the best solutions. So based on the books, there are several types of the sensitivity analysis. So the first one is changes in the coefficient of the objective function. The second is the addition of a new activity. The third is the changes in the right-hand side or RHS values of constraints. And fourth, the changes in the coefficients of the constraints. And the last is addition of a new constraints. So in this case, the analysis looks at two types of changes. We only use the first and the second types. So in the first scenario, we assume that all class options for the course for Analysis and Estimasi Biaya that are represented by X11 and so on until the X14 are scheduled in the late afternoon. So it means that all of these variables have a weight of 1 to the objective value, right? And then, since they contribute to the number of afternoon classes, so as a result, all of these variables directly affect the value of the objective function. So in the second scenario, there is a change in the variable of course 8, which is the course logistic and supply chains system that originally represented by only two classes, x81 and x82. So it's replaced by a new course called Industrial Electronics and Automations, which is represented by 5 classes, starting from x81 until x85. And after that, we do the same thing. We decide the distance variable with the same types xij, but as you can see here, there's a changes in the decision variable. And after that, we also determine the objective function. We still minimize the z here, but as you can see here, there's a difference between the coefficient of k in the courses analysis and estimasi biaya. And after that, we also use the constraints, the same constraints, but there's a changes in the last courses. And after that, we also use the Lingo to find the result of the optimal solutions. As you can see here, there is another class that held in the late afternoon, represented by variable x13. So from this result, we can conclude that by the analysis sensitivity, there is one more classes that held in the late afternoon. I think that's all for me. Wassalamualaikum warahmatullahi wabarakatuh.